Welcome. This is API Evolution Level 2 with Go. If you have not already seen my basic introduction presentation, Level 1, please look at the notes and it will point you to that video. Why did I write this presentation? Well, it is Christmas Eve and I was watching a relaxing video made by Robert C. Martin on clean code. He's more often known as Uncle Bob. Anyway, he says switch statements are bad. And look at what we have here, a gigantic switch statement at the heart of the arithmetic package SumGeneric at the very end of level 1. So how do we fix this? And let's try to understand why he thinks switch statements are bad. He says, Robert Martin, Uncle Bob, says that it violates the open-closed principle. Basically, it says classes or Go types should be open to extension but closed to modification. He talks about subtypes. Now, Go doesn't have subtypes nor subclasses, but it does have this thing called type embedding. To improve our level 1 code, we first need to understand two things: Go embedding, Go type embedding, and also abstract classes, which I will introduce in the form of Go interfaces. Let's first talk about Go interfaces. A common idiom is you want to pass abstract types to functions and that function should return a concrete type. Now, what is a concrete type? This is an example of a concrete type. Why is it concrete? Why is it solid? Because that type has the members A, B, and C well defined, fully defined and implemented. An abstract type, on the other hand, is quite wishy-washy. Here is the definition of a Go reader. It's a standard Go type, but it happens to be an interface and not a structure. And the interface says it must contain a method, and that method is called read. It takes in a slice of bytes and returns two values. Now, this is a Go thing. That's why I didn't want to use the error return in level 1 or part 1. Anyway, Go can return two values: the number of bytes read and whether there was any error when this slice of bytes was read. So abstract types are interfaces in Go. It's an abstract type because, as you can see here, reader does not define nor implement the read method. It only wishes to have a read method. So if we define a concrete type that implements a read method in Go, that concrete type will fulfill or satisfy the reader interface. Here, I define a silly private type called mySillyReader. It consists of one member variable or property. It's also private. And myDat is a slice of bytes, or in other languages, a byte array. And here I define a method called read, taking in a slice of bytes and returning two values: the number of bytes read, an integer, and whether any error had occurred. So all that does is it reads from dat, which is the slice of bytes passed into the method, and copies it into my internal member variable myDat, and it returns this copy function returns the number of bytes read. It returns the number of bytes read and no error. Now let's talk about Go type embedding. What do the types 3 nums and 4 nums have in common? Let's look at it. 3 nums have 3 member variables. They're public, A, B, and C, because they're uppercase. And 4 nums has an additional D, A, B, C, D. If you eyeball it carefully, obviously 4 nums is an extension of 3 nums. However, because of the open-close principle, we must not go back and change 3 nums, because other people using my arithmetic package may already be using 3 nums. If I change it, I'll change it under their feet, so to speak, pull the rug from under their feet and break the contract. So we must not change 3 nums. Instead, let's create a new type called 4 nums EMB, which roughly reads as 4 nums embedded, because it embeds 3 nums. This is how it looks like. 4 nums embedded consists of 3 nums and a new member variable called D, a new property called D. It's public and it is an integer. How do we improve our level 1 SumGeneric function then? Let's look at it again. Our big switch statement at the center of SumGeneric. Using the open-close principle, we must not change SumGeneric because other people may be using it. Instead, let's add a new function called sum with interfaces. And all it does is it takes a summer and returns an integer. It's corny. It's not summer and winter, it's sum. Why? Well, we have to define sum, the interface, as an abstract type, and also make concrete types that satisfy it. This is how we do it. Sum has only one method to satisfy. It is the sum method that takes in nothing. We'll see how it does it later, and returns an integer. Now we can make 3 nums, the type 3 nums, satisfy sum. Now we see how it can satisfy sum. It's got internal member variables A, B, and C already. So sum does not need to take in any additional arguments or parameters. So it just returns A, B, and C, the sum of A, B, and C. Now 4 nums embedded can also satisfy sum because it has A, B, and C from its 3 nums. It contains 3 nums. And we just add on the new D property or member variable. If I look at the GoDoc, the generated GoDoc when I run GoDoc of the arithmetic package, it now looks like this. This was our original sum, our sum 3, our sum general purpose, our sum generic. Now we have sum with interface. And those are the types we defined: 4 nums embedded, generic thing, sum which is an interface, and 3 nums. It's listed alphabetically, not in order of addition, not in the order which I've added the type or method or function. So how do we use our new sum with interface function? Of course, we import our arithmetic package, add 3 numbers, add 4 numbers. Let's look at add 3 numbers first. Arith sum with interface, we pass in 3 nums. Arith sum with interface, we pass in a 4 num. Now 4 num is defined here. It got a bit too long for me to put it in line, so I created a variable to hold it. So it's 4 nums embedded, And this is how we reference our three nums embedded type. It's called three nums. It's explicitly stated here, three nums. It's an arithmetic of type 3 nums 2, 3, 4, and the additional item D has a value of 5. Let's go and run it. It better work. It will work. I ran it before. Some interface, running it now. Hey, it works. Good. Let's go back to the presentation. How have we improved our code? We have removed the empty interface, and therefore we have put Go's safety belt back on. This safety belt I'm talking about is Go's strong static typing. Static typing. Static type checks can now be done at compile time. If we try to pass in a data type that does not have a sum method, the Go compiler will complain when we try to compile the program. Our sum with interface function no longer violates the open-close principle. In other words, new data types are backward compatible with older data types, because 4 nums embedded is simply an extension of 3 nums. We did not change 3 nums, we extended it and called it 4 nums embedded. Thus, 3 nums itself remains unchanged. This is a new take of schema versioning by embedding types with Go. As usual, if you like to download the code to this presentation itself, as well as the code examples, you can get it from my GitHub page, my GitHub repository. Thank you. I'm Siu Yin, and I work for Zendit.